Dear students, today we are going to discuss the relationship between stress and strain. That is about the stress-strain curve diagram. In this connection, the question is discuss the significance of stress and strain curve diagram. See here, there is a curve. It is relates the stress and the strain. The relationship between the stress and strain for different materials is given by the stress-strain curve. We know that the stress, a force applied on a particular area, is called force. Stress. A force is applied here. So its original length is capital L. The change length is L. The stress applied is the stress is equal to force divided by area. Due to this stress, the strain is produced. It is the ratio of change in dimension. So this dimension, it is the original length. This length is changed here. See here, this is the variation of this length. So the strain is change in length divided by L. So we are going to discuss the relationship between the stress and strain here. Under different loads, the stress and its corresponding strain values are plotted here. The strain is given in the x-axis and the stress is applied is given in the y-axis. For different loads, the stress and the strain values are plotted. And the stress the strain graph has different points and different regions. The proportional limit, elastic limit, yield limit, ultimate stress point, fracture and break point is proportional point. From O to A, this area is proportional point, and this region from A to B has some elastic limit. So this whole area, is called elastic region. This whole area is called elastic region. After that elastic region, this point is also called elastic limit or yield point. This point, and then B to C. This here, the point C is a lower yield point. This point extends till D. When it reaches D, it is known as a breaking stress. The breaking ultimate stress point, that is a breaking point. So this area, that is known as a fracture point. Fracture. So from D to E, it is known as fracture or breaking point. The first point is a proportional limit. In this region, the stress-strain curve obeys the Hooke's law. It is the proportional limit. Here, it obeys the Hooke's law. That is, the stress is directly proportional to strain. In this region, it behaves as an elastic body. The point O and A is called the proportional limit. This area is called proportional limit, OA. Here the elastic limit, the region from A to B, here A to B, this area, this whole area are not directly proportional. Stress and strain are not directly proportional, but still the material returns to its original dimension after the force is removed. So it also exhibits some elastic property, but the condition is the stress is not directly proportional to strain. So example for this area, this elastic limit area is spring, rubber band and etc. Next is yield point. It is defined as the point at which the material starts to deform. So here starts to deform. After this yield point, it is a lower yield point. It passed by a permanent plastic deformation here. A permanent deformation occurs. There are two yield points. This a lower yield point and then it is the upper yield point. So this is ultimate stress point. In this point, it represents the maximum stress that material can endure before failure. We see here this area here. This beyond this point, the failure occurs. So the material may break down. Next is fracture or break point here. So in this area, the the point in the stress and strain curve in which the material breaks down. So it lost its elastic property. So it becomes fully plastic. So and then plastic and then other materials like glass, etc. So the material has the different properties. On applying a force, the load and the stress is developed in this material. For each material, there is some limiting point. The first point is the proportional limit. It is coming under the elastic region. It is these materials are wood, rubber, etc. The rubber bands, and this area it is a proportional limit. It obeys the Hooke's law is obeyed here. And then the point here also, the next region A to B, here it also elastic property, but the stress and strain is not in proportional value. And then it goes to the maximum limit, elastic limit. Beyond this, it would not be an elastic material. So here, this whole region is called elastic region. In this area is called elastic region. Beyond this elastic region, the elastic limit has reached, and then the area BC is the lower yield and upper yield point, and then when the load is increases, it reaches to the area C and D. Here it loses almost all elastic property coming to the plastic area. So this whole area is called plastic area, plastic region. And then beyond this, this goes to fracture point. So the materials like glass, so it's breakdown. So the different materials have different property. These are the significance of stress and strain applied on the material.